called the Charles law. The Charles law deals with the temperature, the relationship between temperature and volume. Okay? And the Charles law states that the volume of a system of gas particles is directly proportional to the absolute temperature of fixed number of moles at constant pressure. So we have the quantity fixed, number of moles. We now have the pressure fixed. We're trying to investigate the relationship between the volume and the temperature. Now the temperature, every time you deal with gas law there, the temperature has to be in Kelvin. Okay, it's the absolute scale. So in this case, V is directly proportional to the temperature, or V1 over T1 would equal to V2 over T2. So we can figure out when you have the pressure hold constant, when you hold the pressure constant, when you have the fixed number of moles there, when you change the temperature, the volume will change. There's a relationship. They're inversely, they're directly proportional. The higher the temperature, the higher volume. But the temperature has to be in Kelvin. Okay. This is an example. This is an example you probably see. Liquid nitrogen, negative 196 degrees Celsius, very cold temperature. Okay. If you have a balloon, you inflate the balloon under normal condition, 25 degrees Celsius room temperature. And if you take that balloon, you dip it into the liquid nitrogen, the volume will shrink. If you take that the balloon out of the liquid nitrogen, leave it at room temperature for a while, the volume will expand back to the normal size. Okay, so that's a relationship, indicating the Charles law, relationship between the volume and temperature. The lower the temperature, the lower the volume, directly proportional. The other relationship, pressure and volume, are inversely proportional. Okay, so on a molecular level, how do you explain what we observed here? Well, lower temperature results in lower kinetic energy. Lower kinetic energy results in a slower motion. Slower motion results in lower pressure. Okay, so when you change the the volume and the temperature there, and that's the relationship. Okay, so in this case, we can actually do some experiment there. We can actually plot volume versus temperature, absolute temperature. Now, absolute temperature is something, absolute zero is not something that we can